In this video we're going to look at projectile motion. This is under kinematics. So I'm going to provide notes and tips on projectile motion. Right, so I'm going to start off by looking at an example of a ball that is dropped from a height. So consider a ball that is dropped from a height of 2 meters above the ground and falls to the floor in 0.63 seconds. It rebounds to a height of 1.5 meters, rising to a maximum height of 1.18 seconds after it was released. Draw a velocity time graph and an acceleration time graph of the motion, indicating the speed and time at key points of the motion. Right, so I'm going to use the graph that's already drawn there just to show you how I arrived at these points on these figures 5.45 and 6.35. Now, you've been asked in part A to draw the velocity time graph. So we know that the area under a velocity time graph gives you the total distance moved. So for the first part of the journey, it travels a distance of 2 meters. And we know that it was dropped. So when it was dropped, it means that u is equal to 0. Okay, so the initial velocity is equal to 0 when something is dropped. Right, so and also taking vectors going up, going down is negative, up is positive, so it means its path of going down must occupy the negative quadrant. So in order for us to get the total distance, like I said earlier on, we use the formula area under the graph is equal to the total distance traveled. So we can say half base times height. So the area is equal to half base times height, right, which is equal to half of 0.63, because we told that it takes 0.63 seconds to get to the hard floor, times the height, which is going to be let's just call it V1. So this value here is the V1. Okay, and we know that this area is supposed to be 2 meters, so which means to get V1 we're going to say 2 times 2 over 0.63, and that should give you 6.35 meters per second. Okay, so that is how you get that value. So which means at first you just draw the shape. You know that when it starts off from there, from rest, and it goes down, vectors going down are negative, so which means it has to reach there. That's when it hits the ground. Remember, it hits the ground with the maximum speed, it accelerates, so which means by the time it hits the ground, just before it hits the ground, the speed is the velocity is maximum. Then when it rebounds, it changes direction and starts off with an initial speed which we do not know according to this graph, and then ends, says 1.18 seconds later. So we need to know the difference between these two, that is 1.18 and 0.63. So 1.18 minus 0.63 should give you 0.55 seconds. So again, we know that the area under the graph there gives you the distance. So we're going to say again half base times height, which is going to be half of 0.63, or so 0.55, which we found as our base there, times the height, which we don't know, which we're going to call V2. So this is our V2. So this distance is 1.5 meters, so we put 1.5 meters over here. Supposed to be 1.5 meters, which is equal to half times 0.55, so which means V2 will be equal to 1.55, so it's 1.5 only, times 2 over 0.55, which should give you 5.45 meters per second. So which then you get that. Okay, so that's the velocity time graph. Now in order for you to get the acceleration time graph, I did not include the acceleration time graph, so I'm going to so the acceleration time graph is the gradient of a velocity time graph. Acceleration time graph is the gradient of the velocity time graph. So our graph is going to be like that, with A over there, T over there, and then we've got our 0.63 over there. So this is measured in seconds, this will be measured in meters per second squared. Right, so if you look at this gradient over here, it is a negative gradient, so it's going to be 6.35 over 0.63. That gives you 10, so we get a value of 10, so that's going to be minus 10. So as you can see, the gradient maintains the same value of like the same sign, because it's still negative after the 0.63. That's why I drew a line through like this. So I think that's the acceleration.